Well, hi, good morning. Thank you for joining me here in my shop today for a little more work on this radio, which somehow I thought I was almost finished a while ago, but now I think no. Really struggling with the alignment process here, just getting it straight. I'm still on the basically first time through, ridden off to education. Wow, a real write-off is going on here. Yesterday, while I was working on this, just before my computer stopped, I discovered the AVC voltage was swinging positive. I was seeing it on this meter here. Positive AVC voltage. A, doesn't sound like a good idea, and two, doesn't sound like something that can actually happen. So I want to investigate that while I continue finishing the alignment of the IF. I'm virtually done. Had the sweep thing happening, and it looked like I was getting some kind of improvement when everything went south, because my computer, the hard drive got full on my computer from these large video files, and then it takes me a good hour and a half to sort that back out and get things going again. So by then it's just too late to carry on. So that's why the video ended suddenly yesterday. Let me get everything going here. I got to let the radio warm up for a little while if we're going to do alignment work. And then we're going to look at this, see if we can replicate the positive AVC voltage. And then we're going to, if that's true, then what is that all about? That's probably what I'm going to focus on today, because that's kind of a weird thing. And maybe we'll figure out real quick just what it's all about. I don't know. I'll turn things on here. Okay, things should be warmed up now. You can hear the sound of the sweep in the speaker here, and you can see it on the scope, the sweep result. And already this meter is indicating a positive voltage, positive AVC. Not much. This would be 1.5 volts, 1 volt. So this is 0.15 volts, but it is positive. The interesting thing about that is, where do you get a positive voltage from on the AVC line? I would guess, just off the top of my head, a leak from the B+ circuit, maybe through a capacitor onto the AVC. I wonder if there's something like that in here. So if we follow, let's just follow it. Well, wait a minute, now there's an AVC and a manual switch here, and if you throw the switch, you ground the AVC line. Let's ground it, see what happens to this and this one here. Wouldn't make any difference at all. Did I flip the right switch there? Manual and AVC. It's on AVC. Well, it doesn't make a difference on this meter. It's a little surprising. What if I vary the RF gain, or I think they like to call it sensitivity here. Yeah, this one here. Okay, a little something happening there. Let's turn the volume up. So just turning the RF a little bit and things kind of fade out. Positive voltage. There's another switch here. Let's throw it for fun. Whoa! Wait a minute. What happened there? That's the limiter. That's the limiter's on. We've got that. Limiter off, and I think we have more normal behavior. This is a negative voltage. The limiter is somehow, I'm not going to be able to stand here and figure this out, I don't think, but so the limiter, I'm looking for the switch. Limiter right here. Off and on. So it's off. If I'm reading this right, you close the switch to turn it off. It's going to force the signal just through and through, like just goes through. You turn it on, you open the switch. Now this voltage can't go through that way, it's got to go down through this network, and something happens down here. Is there a positive voltage sitting here somewhere? So I've drawn in red the B plus circuitry, including the screen circuits. There's no red in here at all. The orange is actually the plate circuits, or the plate B plus. You know, there's capacitors to ground off the AVC, but there's not going to be a capacitor back to high voltage. Another one here. That's an interesting question. Why do you get a meter reversal by turning on and off the limiter? Wait a minute, wrong switch. Because something is wrong with this circuit. Would that be the case? And how is the limiter getting its limiting action? Where's, you know, often the limiter would be a diode, I think. Often it's a limiter designed so when the signal gets big enough, the limiter leaks out the top, so it can't get any bigger. And what you get is you get the audio down here below the cutoff, if you like, and then the spike noise, very high spike noise, gets clipped off by the limiter. What's the limiter here? Is this the limiter? So again, if we turn it on, I'm sorry, if we turn it off, we close the switch and the signal just passes right through and out. We open the switch, signal is forced down through this thing here. Somehow a positive voltage is getting onto this from somewhere. But only when the limiter is turned on. Okay, I'm going to go study this, drink some coffee, and ponder that a little more. Okay, well, I'm sure I don't have the story completely right, but I think it goes something like this. How do you get a positive AVC voltage? So normally the AVC voltage is here on this line. And if we track it back up, we see it goes into this integrated circuit, if I can call it that, on leg number, I think that's a 3 there. So I think that's a 3. Right now my voltmeter is connected to, I believe, to this terminal 2. Terminal 2 is a rectified output of the IF, which should produce a negative voltage the way the diodes are turned here. We get a negative voltage here. On the other side of this big 2 meg resistor, typical resistor, is the AVC circuit. So that would be normal to connect here and see negative. Now I see positive. How does that happen? I think this is where things get a little shaky. Here we have the plate of the diode producing the negative voltage. Here the cathode of the other diode is connected. If you study these wires long enough, it's more or less connected in here. And so at that point, what my mind says is, well, this one's hooked up the other way around, or has the other way around effect. Not making much sense, am I? But I think that's the reason. my nonsensical reason. It has something to do with the second diode and the cathode connection coming back into here. Now, is it working properly? I mean, is this what they wanted it to do? Well, because I'm measuring the AVC here, I'm not sure I'm seeing the real McCoy. I need to be down here on the AVC switch. if I get on here, I'm going to measure the actual voltage that's going out to the tubes, rather than something in the middle of this complicated circuit here with diodes going this way and that. So I want to move my voltmeter connection from where it is to, so here it is here. I'll leave the scope where it is. I put the scope where the voltmeter was. I didn't do much thinking. But maybe it too. No, I don't think so. So AVC switch here. And one side's grounded and the other side is carrying the voltage. So I'm going to want to get on here with a regular clip lead. Don't like sticking my fingers into a working radio. I'll stick this metal tool instead. Yeah. Oh my God. Hey, I guess it makes for an interesting video. This isn't working very well. Okay, I'm breaking a rule right now. You see, I'm doing work and I'm holding a spare tool in my hand. Bad thing to do. That's a bad thing to do. That tool goes somewhere you're not watching. Okay, let me try again. Using my fingers. Did I get the other end of that wire? No. Got it. Okay, what do we got here? We've got a negative voltage now. And I'm going to flip the switch. No effect. And how about this one here? This one got to be. This is manual. Put it on manual, you ground the AVC at this point so you can see it went to 0. So there we are, negative voltage gone. My story is probably correct. I was reading it in a place where the voltage does go positive, but it's not important. In the operation of the radio, it's not important. What's important is what's happening out on the AVC line, which is remaining negative. Okie dokie. And let's just fool around with the RF control for a minute here. So I had the RF down a little bit. Okay, and we throw the switch. Doesn't sound any different, does it? If we look at the scope. Here, have a look at the scope here. Okay, this is the RF, and then the switch. This is limiter actually. Not the one I wanted, this one here. This is switching from manual to AVC. So no difference, but we have a very low signal level coming into the radio. So I'm going to pump up the signal level here. Oh, it's still maintaining a lovely shape, isn't it? Wow. You know, so that's what was causing the weird shape. Now wait a minute, I still have the scope connected to the same place as before. I don't get it. But that's lovely. That's just... Hey, I fixed it. Fantastic. Okay, so we're going to turn the volume down here. We're going to crank this way up. Oh man, it never distorts. Never. Well, that's... Wow, okay. This is going to be the limit of my... There, it's starting to distort there, but by now I must have a really strong signal being jammed into the radio. But that's really high. Okay, let's do that. Wow. Okay, that was lovely. Now, wow, what am I doing? Okay, so now I seem to be in a much better position. I don't really know why the image on the screen there just looks fantastic. It sure does, though, compared to what I was dealing with yesterday. Well, I think I should just go back now to checking the IF. I still have the tool sticking out of the radio there. Okay, that's what I'm going to do. But first I'm just going to go drink some coffee. It should be cool enough now. And then we'll attend to the IF with a real nice shape on the scope. Okay, something's really clear now. Have a look at the scope here. That is the signal on the AVC line, if you like, or the output of the detector, with the limiter off. And here it is with the limiter on. Look at that. Let me turn up the signal level. Look at that. Look at that. Limiter off. Limiter on. So this is what was going on with this weird shape. I had the limiter on. Duh. Yeah, that's definitely a duh. Okay, so now we're in really good shape. Everything's looking really good. And what I'd like to know is, what frequency is this right here? And so I do have the other scope going, or the other signal generator going. It's all connected still. So I think if I just sweep this through here, there we are. You can kind of see the wiggle thing happening. How it takes a bit of a sharp eye to recognize when things are perfectly balanced. I'd say right there. So because of the shape of the interference here, it tells me the other signal generator is tuned to exactly the center of that. And look here. Yeah, look here. Look upon the frequency. 454, or on my machine this would be 455 in fact. So I think we got it. Maybe I need to double check this frequency and be absolutely sure it's 455. Okay, I can do that. I can do that. Okay, so first what you're going to check the calibration of the SDR itself. And you can see I have it tuned to 640. That's a radio station. You kind of hear it there in the background. I'll just turn off the speaker. We're going to zoom in so we can see more closely where this is really positioned here. So I think there's little doubt that the station is broadcasting on exactly 640. But you can see the red line is slightly off, and we are talking about a fraction here, are we not? Not much. So we're in this range, so it's a very, very tiny amount. So I'm going to accept it. That 640 on here is really 640. This is a tiny error, so we won't worry about that. Okay, now what we're really trying to look at this funny shape in here. Look at this. I see funny things like this on shortwave all the time. This is the IF of the radio, and this could be because of the sweep. Let me just stop for a moment. Yeah, that's all it is. It's just a sweep, and there's a shutter effect, you know, when you're like the spoked wheel when viewed with a regular film camera, and you get the shutter effect, so sometimes the wheel looks like it's turning the wrong way, all that kind of stuff. I believe these patterns are that kind of thing taking place, with the SDR being the shutter. So this strong signal here is the signal from my signal generator, which I want to have at 455. So let's zoom in on this one now, and we'll see how close we are. So let me set it. Well, this is, wait a minute, 455. So that's exactly 455 there. I'm going to move my signal generator until it's right on top of it. Interestingly enough, I've just proven that my thinking that my frequency counter was one number low is wrong. It's actually, if anything, one number high. So it says 455 now. Okay, so we've proven my check frequency is 455. Good. Okay, so the first thing we want to do again is the check of the frequency. Jim, what are you talking about? Let's check the frequency. What's the frequency, Kenneth? So once again, 455. So let me just shrink this a little bit here. Why are we not seeing any of that signal there? Is it because of this? Oh, there it is. You can see it now. Okay, I'm just looking at it without touching anything. Not quite in the center. I'd say the center seems to be up the side here a little bit. Okay, I'm going to vary this now. I know I've calibrated my frequency counter, so I can get back. So you can see it's up here. A little more. Give me more. Give me more carrier. There, that's a little better. Okay, so there we are. Now we're dead center of this thing. I can now accurately measure the center of this. And the accurate measurement is 453. Not 455. Well, because I want to be so precise with this, I'm trying to push this rate to the limit in terms of getting this done properly. I think I've got to force all this back to 455. The best way to do that probably is to rely on the single frequency signal generator, stop the sweep, tune up the IF based on that, and then check with the sweep afterwards. Why can't I just keep the sweep going anyway? I am feeding for... I can't, the sweep makes a big sound in the radio. And if I stop the sweep though, we should hear this thing. Why would that be so faint? Checking my connections here. I got too many wires on my bench. So this is the signal generator there. It's connected through a resistor into here just to provide a little bit of isolation. I could just boost the signal strength. AVC voltage is not high. It's just not getting much signal. Am I reading this right? So if we jump up the... Yeah. So it's just a very, very weak signal making it into the radio this way for reasons I don't exactly know. It could be hooking up two signal generators in parallel. So we want to boost this up so we can hear it nicely. And then this is now reflective of the single frequency signal generator, and if I vary the output level, there we go, up and down. Very nice. Okay, we're going to set it right there. Arbitrary level. Now, what I want to do is advance the frequency. Get my camera to show everything here that's going on. A little tough. A little tough. I'm kind of using the wrong voltmeter here. I'm just going to set this to 455. Yeah, I'll do that, and and watch what happens to the meter as I do it. Here we go, 455. Meter's going down. That would be 455 there. It went down slightly. And for some reason, I turn this off. Schmozzle. Too complicated. Now it should adjust the IF, bring this back up to the 6 it was, or so, somewhere around there. Oh boy, oh boy, oh boy. Okay, now I'm in the does it really matter the order? So let's just go back to the first one. We should be able to get a raise on every one of these if I had tuned it properly. And you probably can't see it, but well, if we got an increase on that one, it was pretty darn tiny. I'm going to get in the top. Okay, I'm watching very carefully on the meter. You know what? This is all about what's happening with that meter. So you keep a good eye on it. That's probably a better thing. Okay, let me put this in. Okay. Take me to the 6. Oh, now that one went up quite a bit. Okay. Now next transformer into the bottom. This is the one that was hard to engage. There, I'm in. Right there. Now we'll go to the same one in the top. Now this just becomes so easy now. It's because I've sorted all the weirdnesses out. The weirdnesses are gone away. Okay. All the weirdness is gone. This is working just the way you would expect. Some of those weirdnesses were because of me. Okay, just looking over at the IF, my signal generator frequency is still where it should be. Precision is happening finally. Last one, top of this one. Last one. Nothing more to get there. There it is. Hot diggity dog. Now, you can see the frequency is still the same, 456. Flipping on 455 to 456. Very good. Excellent. We should look at the shape. So I'm going to move the IF single frequency out. I'm going to turn on the sweep. We have just a lovely shape there. Now, can I bring the bring this guy back in and just see what happens here? So, okay, so I'm just looking at the scope. I'm not going to look at the frequency here. And we'll set this. Right there. That's a sweet spot. By Jove. I think he's got it. I think he's got it. Okay, there we are. I have properly tuned in this radio. Yeah, a bit of a long journey, but that's great. Now we just have to go through all that RF stuff again. And with great precision and care, and hopefully all the bugaboos have been knocked out of the RF alignment issue, and I've got my head straight. Fantastic. It's another beautiful day here. It was very cool this morning when I got up. The sun is shining. It's not going to get hot today. It's going to get warm but not hot. Fantastic. So once again, if you're in part of the world that is suffering from heat and floods and all this stuff that's going on, I feel so sorry for you, and I'm afraid I'm off to enjoy my day. Thanks a lot for watching, and tomorrow we'll get back to the RF alignment and I'll carefully go through it properly, and we'll see if we can't get this guy 100%. Thanks a lot for watching. See ya.